You ever stop and think about the invisible forces that are, constantly powering our world? I'm talking about everything from the battery in your phone to why an apple turns brown after you slice it. There's this fundamental chemical process happening all around us and even inside us every single second. So today, let's dive into this hidden world of what are called redox reactions.
Okay, so to get started, let's solve a little mystery. You've probably seen these, right? Those disposable hand warmers you crack open on a super cold day? You open the packet, give it a little shake, and boom! Within minutes, it's making its own heat. It totally feels like magic. But what is actually going on inside that little pouch?
Well, the secret isn't magic at all. It's pure chemistry. What you're actually holding is, well, it's a tiny, controlled chemical fire. Seriously, it's a reaction that's been perfectly designed to release its energy slowly and safely, as heat. And this simple, kind of brilliant idea is our ticket to understanding a much, much bigger concept. So yeah, let's start right there, with that power you can literally hold in your pocket. This little hand warmer is the perfect, everyday example of our core topic today. So what's actually in that little packet? It's basically just super fine iron powder. The second you tear open that package, you're exposing that iron to the oxygen in the air. That kicks off a reaction called oxidation. You probably know it by its more common name, rusting. This whole process is exothermic, which is just a fancy way of saying it releases energy as heat. And that's what's warming up your hands, a simple but really powerful transfer of energy. But here's the thing, that word oxidation, it's only half the story. It never, ever happens alone. It's always part of this chemical partnership, a perfect little give and take. This whole process is called a redox reaction, and it's basically the great electron exchange that powers our entire world. So, what in the world is a redox reaction? Well, to put it simply, think of it like a perfect chemical trade. One substance loses electrons, and at the exact same time, another one gains them. The key here is that they have to happen together. You can't have a seller without a buyer, right? It's a perfect, simultaneous exchange. All right, so let's break this partnership down. The part that loses the electrons, that's called oxidation, and it happens at a place called the anode. The part that gains those same electrons is called reduction, and it happens at the cathode. Now, if you want a super easy way to remember this, just think of the phrase oil rig. Oxidation is loss, reduction is gain. Simple as that. Okay, so this predictable flow of electrons, that's the real magic here. The big question is, can we actually do something with it? Can we put it to work? Oh, absolutely. We can harness that flow to create electricity. And that, my friends, is the basic principle behind every single battery ever made. Let's see how it works. Okay, imagine we're building a simple battery right here, right now. We'd start with two separate little containers of liquid. One has what we call an oxidizing agent. That's a substance that is just dying to gain some electrons. The other has a reducing agent, a substance that's more than happy to give its electrons away. Now, on their own, nothing happens. But the moment we connect them with a wire, we create a pathway. The electrons start to flow from the giver to the taker, and that flow of electrons is an electrical current. And here's the really cool part. This isn't some invisible, abstract concept that's just happening in a wire. In a chemical setup like this, you can actually see the proof of this electron transfer with your own two eyes. This is it. This is the proof. That deep purple solution, as it accepts all those new electrons, as it gets reduced, it undergoes this dramatic color change, fading away to almost nothing. You are literally watching chemistry in action. It's the visible evidence of that invisible flow of energy. Pretty cool, huh? So, okay, we can make a current in a simple little cell, but what if we could take that idea and just perfect it? What if we could build a system that basically never runs out of juice? Well, that's the whole idea behind a much more advanced application, the incredibly clean and efficient hydrogen fuel cell. Just think of a fuel cell as a battery that never dies. Instead of having all its chemicals sealed up inside, it's constantly being fed fuel from the outside, in this case, hydrogen and oxygen gas. It uses the exact same redox principle we've been talking about, transferring electrons to create a current and turning chemical energy directly into electricity whenever you need it. And this is the truly incredible part. In this reaction, hydrogen loses its electrons, it gets oxidized. Oxygen gains those electrons, it gets reduced. And when they combine, the one and only byproduct is pure, clean water. No carbon dioxide, no pollutants, just H2O. I mean, the potential benefits here are just huge. Not only are these things super efficient with zero emissions, but they could dramatically reduce our dependence on foreign oil. The tech is so clean, in fact, that on space missions, astronauts can actually drink the water that these fuel cells produce. It's a power source and a water purifier all in one.
Okay, but let's be real for a second. The technology isn't quite ready for prime time just yet. The biggest hurdles right now are cost and durability. But the real challenge is the fuel itself, figuring out how to produce hydrogen cleanly and then store it safely. Those are massive engineering problems we still need to solve before we see this tech in every car on the road. All right, so we've covered everything from pocket hand warmers to futuristic fuel cells. But the real takeaway here is that redox reactions are already a huge part of your daily life in places you would probably never, ever expect. You ever seen a breathalyzer test on TV or in a movie? Well, that's redox in action. The device has this orange chemical inside that reacts with any alcohol on a person's breath. The alcohol gets oxidized, the chemical gets reduced, and that electron trade causes the color to flip from orange to green, a super clear sign that alcohol is present.
Or what about a glass of wine? To keep it from spoiling, which happens when it reacts with oxygen, winemakers add antioxidants like sulfites. These little guys are way more willing to be oxidized than the delicate flavor molecules in the wine. So they basically sacrifice themselves to the oxygen, protecting the wine in the process.
And yep, even something as boring as doing your laundry. When you pour in chlorine bleach to get out a really tough stain, you're using a powerful oxidizing agent. The bleach attacks the molecules that create the color in the stain, and through a redox reaction, it just shatters them into smaller, colorless pieces. So there you have it. From warming our hands, to powering spaceships, to keeping our clothes clean, this fundamental exchange of electrons is absolutely everywhere. It's basically one of chemistry's most essential tools, like a universal power switch for, well, everything. The only question left is, now that we understand how to flip it, what incredible problem are we going to solve with it next?